welcome to session 9. So the session 8 will be after this on the environmental or the data management platform. So we are here to present the digital tools for lifecycle assessment and environmental product declarations. Go to the next slide, Christina. So there are two core teams that are involved in this in DigiEcoQuarry regarding the environmental platform. So it's us from Chalmers, myself, Gauti Asbjörnsson, I'm associate professor at Chalmers, and Christina Lee, who is a PhD student. And besides working on environmental product declaration for aggregates, we deal with discrete, static, and dynamic modeling and simulation of aggregate plants, and some process control for crushing and grinding, as well as platform development for process environmental evaluation. And with us is also Rock Team. It's a spin-off company from the university. So we have Adam Sköld, which is an application specialist, focusing on the implementation and the day-to-day operation of the platform. And besides working on platform development, Rock Team is also dealing with process automation for aggregate production and crush and control algorithms. So how do we fit into the DigiEcoQuarry projects? We are responsible together with the University of Leopen on the environmental impacts of the quarry operation, not only the emissions, but kind of maximizing sustainability and resource efficiency. That includes reduce emission, but kind of improve resource efficiency to have a more sustainable supply of aggregates. And if you go to the next slide, Christina. So we are involved in all 5 pilot sites that are within DigiEcoQuarry projects. So we are SPCAT, CMX, Holcim, CSI, and Simpor. We have done a state zero evaluation of the sites, meaning that what's the status of the plants before we started the project. And now with the integration into the digital platform, the IQS, we can start to see a little bit more of the improvements that we are trying to achieve with the different applications. So we are involved in all the pilot sites. And with that, I'm going to hand over to you, Christina, who has some hands-on interactive activity planned.
Yeah, exactly. And I think as before I kind of get into a little bit of the background as to how we're doing the environmental calculations, I thought it would be good to start with kind of thinking, what is environmental? What are the big concerns when it comes to the environment and aggregate production? So I hope that a few of you have your phones nearby, and we will see if this works, because it's the first time I've tried using forms. Oh, that didn't work. See if it loads. And I should come up with a QR code here to go into a question. And I just want you guys to write down, what do you think the biggest environmental concern is for aggregate production? Is it going to work though? Let's just see if I can go back one and get it to load. Now it looks like it's going to load. Or not. My computer may be a bit slow today.
I think it's coming in, and it gives us some time to take out our phones for the actual.
There we go. So yeah, if you just scan the QR code, it's one answer questions. Please feel free to write down what you think the biggest concern when it comes to the environment is and aggregate production. And there will be, hopefully we'll be able to see some answers coming in on the screen. I'll just give it a minute or two and see if this does work or not. We have responses coming in. Perfect. So yeah, I'll just give you 1 minute to write down what you think. Brilliant. CO2 coming up a lot, yeah. Water use, landscape, yeah. transportation. See if we get a couple of more responses coming in before we move in. Water coming up a lot. And of course, yeah, diesel. This is great. So what you can see, there's already a few different things on the cards, if you can say, when it comes to environmental concerns. And with many different concerns that are apparent, there's also many different ways that you can measure and look into these environmental concerns. And so what we're using in the project is LCA, or life cycle assessment, which is just one method that can be applied when looking into environmental concerns. And one of the advantages with using LCA is that you're looking at all stages of the process to try and identify a range of different environmental impacts. And that said, some impacts aren't included, and that's also important to have in mind, and something we'll discuss a little bit later. But LCA tries to quantify. It's at the end of the day, it's an estimation of what the environmental impact is, and it focuses a lot on emissions, so things like carbon emissions, on acidification or eutrophication, so things that can impact our nature through the release of gases like carbon dioxide, sulfur dioxides, NOx emissions as well. And one of the benefits of using it is that you can try and identify trade-offs to see, so that environmental impact isn't just shifted from one part in the production to another part in the production. And so what we use is we use life cycle assessment within the EPD framework, which is the environmental product declarations. And one of the reasons why we use this is because it's highly standardized, and this allows for better comparison of results between products that are performing the same job. And so here you can see an overview of some of the most important standards that are within the framework. And it kind of goes down in specificity. Great word. I can never say it very well. But starting at kind of more general rules for that can be applied to many different products, and gradually getting more and more specific. And so you've got looking at construction products in general, and down to then aggregate production. And that's in something that's called a sub-PCI, or sub-product category rules standard. And there's not actually one of these available within the system that we use in DigiEcoQuarry, but it is under development. Yeah, the release dates for that is 2025. And I've been talking a lot about the product, and that's great, but a product isn't the only story here. We are working with quarries, and there is overlap between the product life cycle and the quarry life cycle, but sometimes there's are factors that aren't considered when you take one or other perspective, and that can also be something that's worth having in mind. And so we're trying to work a lot more with getting waste management. Here you can see that kind of taking the product life cycle, really focusing on the extraction, processing, and transportation phases within the quarry life cycle. And we're trying to expand that much more into waste management as well, and a little bit of site closure when restoration is taking place within the year of focus for the study, since the EPD framework takes 1 year of production into mind when you're doing the data collection. And so as you can see here, here's a screenshot out of the new standards that will be at the product level. So for aggregates specifically in the sub-PCI I mentioned earlier. And you can see here, this is where we're trying to get more, take more account of waste management, including waste products from the quarry itself. And going through kind of the main activities that take place in the quarry. You've got your site preparation, your blasting, if it's a hard rock quarry, or extraction if it's dredging or excavation based. Your transportation, your storage, and the actual processing of the material itself, the crushing and screening and washing. And so it's split up into these different phases of the life cycle here as well. And we have a specific terminology used when we're talking about these different phases. So A1 is talking about the actual raw material supply. A2 is about the transportation of that material. A3 is about the manufacturing. And then A4 is the external transport. So that's your transport out to your customers at the end. And what's actually included then in the studies can vary a little bit, considering this life cycle perspective. And so what we include for the EPD studies for the aggregate project is the A1 to A3. So your transportation out to customer is not compulsory to include. And it's also then including the end of life of the product, not the quarry at this point, but the product. So that's the disposal after it's gone through its usefulness, which is also a little bit unclear. So that's where some work has been done in DigiEcoQuarry with actually kind of developing some scenarios as to what can happen to material in this phase. And then there's also this extra tag on, the plus here, for a D module. And this is talking about benefits and loads beyond the system. So what we mean there is what happens outside of this very specific production system. So if you recycle the product, then you can actually replace that product being used again. And you can get some benefits from that. And so now kind of moving into what information do you actually need to gather and think about when doing these studies. And one of the first points is actually think, well, what is it you want to look at? How are you going to do your comparisons later if you want to be able to compare one study to another study or one product to another product? And this gets quite difficult for aggregates, since aggregates have many, many different uses. You can't say that it's definitely going to be used to make a concrete, or definitely going to be used to make a gravel driveway. And so instead of using a functional unit, which is quite common in life cycle assessments, where you're thinking about how much floor do you need to, or how much material do you need to lay 1 meter of floor, for example. We use a declared unit. So that we're talking about 1 ton of aggregates product. And so when we're talking about the results, it's always relative to that unit of 1 ton of material or final product. We also need to collect data then on the quality or to collect information on the quality of the data used. And so this is also something that's quite standardized within the framework. And we talk about data being of very good quality to very poor quality. And to try and get as much information as we can about that and make it useful in making decisions. That's considered on a geographical perspective. So how representative is the data of this specific location? The technical representativeness. So how well does the different technologies are used in the data or the data sets match what is actually being used on the site? And then the time representativeness. As I said, we're looking at 1 year's worth of data. So is that the data used representative of that specific year, or is it taken from previous years because the data couldn't be found, or is it from generic data sets that are much older as well, is a possibility. So that's some of the aspects of quality that we talk about when collecting the data. And so in the end, what we're collecting for the sites in DigiEcoQuarry is this modules A1 to A3, so the extraction, transportation, and manufacturing, and then these use phases at the end. And then for that, we need to gather information on all the materials that are coming into the process and the materials that are coming out of the process. So your diesel use, your explosives, if you're blasting, electricity, of course, and any waste material coming out of the system, as well as actual products at the end of the day. So it's quite a lot of data, a very data-intensive process here. But at the end of the day, you get quite a lot of information out as well. So these are all the different environmental concerns that are actually included in the studies. And so it's 13 main kind of impact categories, thinking about global warming potential, so that's your carbon emissions, acidification and eutrophication. So this is the potential to acidify an environment, the production of acid rain, eutrophication, the over-fertilization of different landscapes out in nature. So then more kind of practical parameters about like the hazardous waste or non-hazardous waste that's coming out of the system as well. And so the idea of this is to be able to be comparable across products. And so here you can actually see a sample we've taken from Sweden where EPDs are being produced for aggregates. And you can see how it's quite a wide spread, and this is for carbon emissions here. So this is the kilograms of CO2 equivalent per ton of aggregate produced. So it can be as low as 1 kilo there, up to about 8-9 kilograms at the very, very far end, the little outlier there. So it's quite a big span, and that really shows how this method can capture quite nuanced differences between different production systems. And as I said, this is quite, and hopefully you kind of got the impression now, this is quite intensive. There's quite a lot of work that goes into this. And because of the standardization, you have to decide on where you want to publish this, make sure you're following that specific rules. So it can be quite intense for producers and quite daunting as well. And so part of the work in EPD, in DigiEcoQuarry, is to make these EPDs a lot easier and more accessible to producers by reducing down a lot of that work time and data intensity. And how do we do that? It's through kind of creating templates so that there's less work having to do the same thing each time for each different producer. And since there's a lot of documentation that needs to be sent away to get your EPDs, as well as the EPDs themselves, which I didn't mention that PDF documents at the moment. By also taking a more modular approach to the LCA studies, so that it's easier to find data sets, which is a big challenge for a lot of people doing LCA studies. Generating reports so that there's less work there for them, and pre-verifying the data. So this data quality check doesn't have to be as intensive either. And so, one of the methods that we're using to make this easier is through using a modular LCA approach. And this is quite, I won't go much into this because it's getting very much into the details of the LCA, and that's quite a big topic in itself. But the idea is that by creating the tools that we're using in DigiEcoQuarry, we can get a much better detail level, so at kind of the machine and production line. And with that, rather than just having this document, which is often used for communication, you can actually start to identify areas for improvement within the production process. And how we actually take on that modular approach is by kind of grouping our activities together. So for different system inputs, for example, diesel, we collect transportation, production, and consumption into one module. And so then you can use that to kind of scale to your exact production circumstances. And so since these EPDs are pretty intensive, you've got to wonder, why do people do this? And for very good reason. It's very, very useful for it is a communication tool at the end of the day, used for business-to-business communication. And that can really give you an advantage in the market. And as you can see here, this is EPDs across the construction sector, so not just aggregates here. And you can just see it's growing and growing and growing as more and more businesses see the advantage of being able to actually provide information on their environmental performance. So it's a real advantage, I think, especially as new standards and new requirements come from the EU to report your environmental performance. And so I just kind of wanted to end this. We talked a little bit of an introduction to EPDs and LCA as the methodology used within DigiEcoQuarry. It's very useful to get all this data out, but there are limitations. One of the limitations I haven't actually put on here is the fact that it doesn't cover all environmental impacts. So some of the aspects that was lifted there in the first session, like land use, very, very poorly covered at the moment. But there's a lot of development work going on, which is great to see. So hopefully that will change over time. But yeah, at the moment, it's just a PDF document used with communication tools, which is not so helpful for aggregate producers wanting to actually improve their environmental performance. It's time consuming, as we've discussed a little bit here. And even if the goal is comparability between products, there's a lot of questions as to how well that comparability is achieved in real life. And that's where these tools can help with that by standardizing data as well in the background. And there are not just one operator that's running EPDs as well. There's quite a few different ones across Europe. And so there's a lot of work to be done with harmonization. So an EPD produced in France or Germany under one EPD operator is comparable with then somewhere an EPD produced in Sweden or Italy under a different one. So that was a very quick crash course in the background of EPD and LCA. And Gauti is going to talk a little bit more about how this all fits into the work we've been doing in DigiEcoQuarry.
Let me just take over the screen.
Stop sharing.
So can you see my screen?
Yes.
Yes.
Perfect. So when it comes to kind of the development of a digital tool for environmental product declaration, there, as Christina was kind of touching upon, there's a lot of restriction and flexibility in the framework. So we need to kind of consider that in the development. And when we are dealing with a complex system, communicating with other servers and other systems, we need to consider the interoperability, that we're actually able to communicate with the different system and have the right structures for that. And also, since we are dealing with a lot of information, the issue of visualization of the information is a key part, as we want the producers to actually use that information, not just be collecting the information, but being a little bit more proactive in their environmental actions. So from the research group, we developed this process simulation and environmental platform, Plantsmith. And that has kind of spun off into 3 different projects, one national one, which is EPD Bergen, and 2 European projects, where we are using kind of the modularity of the platform in different ways, either more as an EPD generator in the EPD Bergen, or as an integrated system in a much larger platform in DigiEcoQuarry and in Rotate, which has a little bit more a specific functionality in a larger context. And this is kind of how we would like to kind of illustrate the workflow that you have with Plantsmith, the kind of the base platform. And if you're interested, you can read the Christina's licentiate that she published a month ago or so. But if we start from the top part here, the tool components, everything is in-house developed. So we have full flexibility of both the back-end, front-end. And as I mentioned, this is not just an environmental platform, but a process and environmental platform. So we do have equipment models for all the equipment that we need in an aggregate plant. And those are kind of continuously expanding as we see the need for new models. We also have the simulation core, which is a steady state simulation, also in-house developed, where we do as a steady state simulation to achieve mass and energy balance. And externally, we are communicating with an LCA server, LCA database that is responsible by the Swedish Lifecycle Center, or Swedish, the Environmental Institute of Sweden. So we are communicating that with an API. So we're not only having it on a local, a cloud server, but also communicating with other servers through an API. And the LCA models are based on Gabi, or Sphera as it's called now. So when we start setting up a process, we start by creating a process layout of the site. A picture. Yeah, so we create a layout of the site. We specify the product groups that are within the quarry, and we enter the empirical data into our EPD module within the platform, meaning that we add the consumables as well as the production data over the year that is needed for the for the EPD documentation. Then it goes through the direct mass and energy balance that we are creating with the simulation core as well as the process models. And then we get a suggestion of allocation of energy and other resources on the different product groups based on the model that we've set up. And then it's normalized to empirical data, meaning that we have, as Christina mentioned before, we need to look at it per ton produced. And then we get the results from kind of the individual LCA, meaning that we can allocate individual consumables on different product groups. And then from there, get the emissions that are associated with each group. And these are then all entered into specific LCA and EPD report templates. Which is in line with what Christina mentioned before regarding the A1, A2, and A3 categorization. So when we have the results, we can start looking into, for example, a contribution analysis where we identify which consumable is contributing more to different factors, as well as sensitivity analysis, varying different inputs to see how sensitive the process is. We need to make the quality assessment that Christina mentioned before, of how good quality of the data do we actually have. Then again, more on the kind of quantitative analysis, how good are the results reflecting on that, and if there are any other specific information, environmental information associated with the site. And then from the user perspective, we create those EPD and LCA reports, which are in a Word template, making it accessible for the user to adjust. And if they have plant-specific information, they can add into that. And that goes into a Word template, so they need to be able to adjust that. On top of that, we have the JSON file, including all the information for the process simulation and the environmental impacts. And those are fairly heavy files. I mean, they are at least 7,000 lines of information. So, and then if you have multiple product groups, that will kind of expand as well. So it's kind of minimum 7,000 lines of information. At the moment, these are PDFs. The EPDs are PDF documents. There are, however, standards in place for digitizing EPDs, meaning going from a PDF to a more machine readable files. Then we can, instead of having those PDF documents and going manually and extract CO2 or reading the CO2 emission, they can be imported and exported into third-party software. So it's the ILCD plus EPD format, which is kind of defined for the EPD documentations. And for most tools, these are in place, but they are not that accessible at the moment as a machine-readable files in the databases that you can find EPDs. But from my understanding, most of it is in place now to be rolled out. So this is coming quite soon. So to kind of focus on the key enablers for a digital environmental tool, one of the key aspects is the modular LCA that we have in the background. So it's time consuming to create the LCA model of the process if that's done by hand. But with the modular LCA, you can instead focusing on the consumption of the consumables. It helps organizing and managing the data sets. And then it helps us focus on the product lifecycle instead of the quarry lifecycle, as Christina mentioned before. Then having a digital infrastructure in place, which we're going to probably hear a lot more in the presentation from our code, is that a lot of the manual labor that is needed for EPDs and LCA that can be automated. And when it's automated, it reduces the risk of human error, as well as kind of creating consistency and comparability in the data that you're actually looking into. You have the same or similar assumption, everything's clear on that, and kind of minimizing the resources needed to actually generate an EPDs. So you don't need an LCA specialist to do the documentation. Most of it you can do in-house, and with some training you can do the interpretation as well. And data interoperability, ensuring that we have the right communication and the APIs and the data exchange format between the different systems. So it's the exchange of the information goes seamless between different systems. And how do we fit within the DigiEcoQuarry IQS system? So I stole this slide from the Sigma presentation a couple of weeks ago, and it's kind of describes well how Plantsmith fits in. So it's one of the expert systems. So we are communicating with the data lake and the data warehouse. So in all Plantsmiths, we are both receiver and producer of information. So we are both kind of pulling in information and giving away information to the data lake. So from the data warehouse, there's some data analysis and data reporting that's happening, and then information is collected in the dashboards. There we have had a lot of discussion with the coders, kind of how to set it up, how we would prefer the visualization, and what options the operators can actually have when kind of selecting the data sets and the visualization. And how it goes on kind of from a more practical point of view, we have our pilot sites which are uploading both production data and consumables, meaning that what products that they're actually producing and the consumables under a certain period. So EPDs are done on a yearly basis, but within a DigiEcoQuarry, we want to have on a monthly basis to have a higher resolution of information, so the process operators can actually be more reactive to changes in the system. And that goes into the IQS in partially the IQS plant production part, and as well as the environmental data management part, where Plantsmith receives production data and consumables and does the calculation, does the allocation of the calculation, and uploads the LCA and EPD results. This is then viewed through the environmental management platform. And we have started to get some results. So these are snippets from the state zero evaluation that we have done. And I mean, of course, there will be differences. And all sites are not completely comparable. So they have different situations that's happening here. For example, you can see that site 5 here is extremely high compared to the other sites. But what is specific in this case is that they needed to account for external transport, meaning that the transport of material was not all happening inside of the quarry, but it was also happening outside of the quarry. So that needed to be taken into consideration. And for most quarries, the diesel consumption is the highest contributor to the CO2 emission. And we are only showing 3 impact categories, but as Christina showed before, we have 13 core categories and then additional 20 or so that show different information. So we cannot only focus on CO2 emission, but we need to also have it relative to other to the production site. So that's where kind of the IQS comes into, kind of that we can store information and then we can create different dashboards to make it relative, because in most cases the CO2 emission, you can put it into a context of what you are familiar with. But with other categories, you might not be familiar with how to put it into a context. But with a visualization like we're doing in the DigiEcoQuarry, it helps with the interpretation of what is actually affecting what. And I also stole a video that Sigma did in a previous presentation to demonstrate a little bit the kind of the possibilities that we have for the visualization. That, as I mentioned, there's a lot of impact categories that you're actually dealing with, and we are having a higher resolution of information, so it should be easy to change between different years or different months, or looking at different consumables and how it is affecting each other with the different product groups and what is actually contributing to the different products, so they can actually use that information to work actively with their, well, minimizing environmental impact. Pause this and move on. So the insights that we've gotten from DigiEcoQuarry and the other projects, so when the quarry start working actively with the information gathered, not only the direct quantification of diesel or water or explosives, but kind of how it's affecting the emission that both blasting and diesel consumption are affecting the CO2 emissions, or how transport distances are affecting the diesel consumption, then in turn affecting the emission. So the kind of the key part is kind of reducing diesel consumption is a good way of achieving better environmental impact, but also not forgetting the machine utilization or identifying use cases for inert rock wastes to kind of even out the distribution of impacts. And kind of with tools and more a digital structure, you can work a lot more with finding an optimum for your production from an environmental standpoint, not just yield or cost benefits, but from an environmental standpoint as well. And kind of rounding off that, when we have digital EPD tools and digital EPDs, there's a lot more that you can actually do with that information. And one of the key part is using that information in BIM models, building information modeling. So if you have a specific quarry that you're actually extracting material from and using in the construction, you can use that specific site-specific EPD to prove that you're actually working more actively with the environment to kind of minimizing your impact. Getting better resolution from mass flow analysis, kind of what is impacting what. And also in GIS models, finding out, connecting those digital EPDs with the quarry locations and integrating that with maybe a construction project, ongoing construction projects, to find hotspots of where you might go for electrical transport instead of diesel transport if it's a longer distances that you would not need to transport the material. So there's a lot of potential with the kind of digital EPD tools and digital EPDs. So the challenges that we have faced with creating a digital EPD tool. One key part is that we have multiple different users with different perspectives, different requirements. So there has to be customization possible within the platform and the visualization of the data. As I said, we want to be quite close to the machine line and the equipments. So having different levels of machine models for the operators to actually input into the system is a key part. As I say, we are dealing with the multiple variables and from the LCA. So kind of visualizing that in a more comprehensive manner is a key part. As I mentioned before, we are dealing with a system within a system, maybe within a system. So the kind of key part is the communication between the systems, that we have clear hierarchical structure, digital structure with the formats well in place. And what we've seen in the kind of issues that we have, one example is the naming of the variables. That key part is having that harmonized to kind of be able to automate the communication with new queries or new variables that are being entered into the SCADA system. And it might be simple as, well, if it's spaced in a variable name or a caps lock or, yeah, simple things. But they cause problems in the integration. And then the regulatory requirements, since we are basing the calculations on standards and regulations, there are some parts of the frameworks are rigid, some are flexible, so that the assumptions and the updates of the standards need to be accounted for over time. So the overall advantage is kind of summing up within our time frame here. What we want to achieve is kind of high comparability of the environmental information from quarry to quarry or product to product. And with the platform and digital structure, we kind of ensure consistency, comparability, and reproducibility, that we can actually recreate that information quite easily. The key part here is a more efficient workflow. It takes time to collect the data, do the LCA assessment, do the reporting, do all the documentations, and get to the verifier, and the verification process is time consuming as well. So with a tool, you can automate a lot of these procedures, as well as from the producer side, as well as the verifier side. Since with the tool, you can have it pre-verified, then it's more efficient for the verifier to have a pre-verified data that they're actually looking into. And integrating the environmental impact with other parts of the operation, you're kind of minimizing the need for specialized knowledge. A lot of the EPDs and LCA done at the moment are through consultants. So the knowledge is not within the quarry level. They have external consultants that are doing the work for them. So they're kind of the gains that you can get from collecting the data and doing an analysis and doing the assessments and the interpretation yourself, most of it is lost through a use of external consultants. So with the tool, it's more focused on getting the knowledge for the interpretation that is more easily achievable than knowing how to conduct an LCA. That's a lot more comprehensive knowledge that you need to have for that. And also for the kind of more frequent estimation of environmental impacts, like we're trying to achieve with DigiEcoQuarry, we can use that information more proactively and have environmental KPIs as a part of the strategic planning for the quarry to minimize the overall impact of the process and the quarry. Yes, so with that, I would like to thank you for listening, and thank you, Christina, for also contributing to this presentation.